So today we are gathered here to discuss the memory of the applications that we've lost and a little bit of the life that they've left behind. Through this talk, Alex and I are going to be discussing iOS and Android, and we're going to be discussing how even though the application itself, the entire container may be blown away, there's a lot of artifacts that are left behind that we can track. So my name is Christopher Vance. I am the manager of curriculum development with Magnet Forensics. I'm a mobile researcher for OS file systems, for applications, pretty much anything I can get my hands on. And honestly, I just like to break things.
My name is Alex Brignoni, and I work in federal law enforcement, and I'm a forensic examiner full-time. And maybe some of you that are really attuned to fine entertainment heard our walk-in intro, The Undertaker, WWE, totally appropriate for talking about deleted apps and things that have passed away. And we want to start with having a quick discussion on what's in it for you, right? Why is this important? Why are you interested in deleted apps and some artifacts related to it? Mostly, at least from my perspective as a criminal investigator, we're really focused on the data that's user-generated. We want the picture that was taken. We want the chats that are incriminating. And that's fine, and that's all good, right? But sometimes what's not there can lead or tell you more than what actually is, right? Sounds a little bit counterintuitive, but that's the case. In many situations, when you don't have user-generated content, the aggregation of all these artifacts of deletion can really bring a case to closure, right? And I have a couple of examples, right? These examples are, like they say in the movies, right? Fictional, like there's no similarity between fictional and reality, and are or based on true events. So either way, okay? So let's talk about quickly one of the most typical cases I have to come across with child exploitation material, right? You might go to a location that contraband has been distributed, and you go to the place, and there may be 15 possible suspects at that location. And you look at the devices on site, and you don't find the possible app that you're looking for, right? If I'm able, on site, triage and figure out which of these phones had that deleted app, that will tell the investigators who they might need to focus their investigation on, right? Might even tell them some of the period of activity that app was being used. The app's not there, but we can tell some of the periods of activity and what type of activity might be happening. And you can put those pieces together and push that investigation forward, right? Another example, how you get more data from a deleted app than an app that's there. Imagine this fictional scenario. You got a victim that's been murdered, and you find the device, and you find that there's an app that's been deleted post what we believe would be the time of death, right? So obviously somebody, not the victim, deleted this, right? And it might lead you, for example, to an app that's tied to a video surveillance system. And video surveillance systems today keep the recordings where? In the cloud, right? And it might lead you to have the understanding of who, as a law enforcement agency, who to subpoena and get information. You might get actual recordings that might be pertinent to your case. Does that make sense? So taking that into account, we divided this analysis between Android devices and iOS. And Chris is going to start talking and explain to us what he has researched in regards to iOS.
Right. So really for iOS, it's all about the bundle ID. Once we find the bundle ID, we can really start to track a lot of the deleted information. And this is going to be really the core part that we're going to look for. So the app itself, when you delete an app, it's supposed to delete the entire container. Well, in iOS, that's actually two separate containers. There is a container for the app itself and all of the package information for that app. And there's another container, shall we call it, or folder, honestly, that's there for the documents and data for that application. And depending upon how the app is deleted and whether or not it's truly deleted depends on if the data still remains. And in iOS, there's actually two different ways an app can be deleted. An app can be deleted, or an app can be what's called offloaded. An offloaded app is a deleted app because it deletes the app. But in an offloaded app scenario, it doesn't remove the documents and data container. And that container is still 100% there and trackable for all the information. There's also native files and databases that we've used for a long time. We have things like PowerLog. We have things like KnowledgeSee. These amazing native artifacts that we've always used to track and timeline these events, well, they're not actually being called back to and being told this application is removed, go remove the traces of this application. In some cases in my testing for iOS devices, I downloaded an app and used it for about a week. 9 months later, I was still able to go back and track the usage of that application, even though I'd only used it for a week and then deleted it after 7 days. So there's a ton of information there. Unfortunately, because it's iOS, and iOS does this all the time, not every app is going to be exactly the same. So what we're hoping to do is give you a methodology to understand what artifacts you can look for and kind of where you can go that timeline. So let's talk a little bit about offloaded apps. Apple allows users to offload their apps in order to save space. Again, they're deleting the app itself, not the documents in data. So you can see here from a screenshot from totally not my phone, because who would play Harry Potter? Not me. You can see here that I have an application. There's two ways you can do this. One, you can actually enable this for all apps, and then Apple will actually look, thanks to the databases we know and love, and see how often you're using these applications. And if you're not using them very frequently, they'll say, okay, fine, let's just offload those to save space. You can also specifically choose an individual app from the usage area and then go in and remove that app by saying offload app. At the top here, you'll actually see we have an app size and a documents and data. It's the app size that they're tracking in that container which actually gets destroyed if, and only if, they offload the app. A true deleted app, as in you hold down on the app icon on the screen, everybody starts shaking in their boots. If you're an iOS user, you hopefully get that joke. And then when you actually press the X and delete the app, that's what causes both of the containers to actually be purged. So when we talk about these containers, where can we track them? This is actually incredibly annoying when dealing with the raw file system of an iOS device. If you're used to dealing with an iTunes backup, you may not recognize these, because in an iTunes backup, it's usually listed by the domain name. Yep. But if we're dealing with a true full file system from an iOS device, whether it be a jailbroken device, from a gray key extraction, from a Celebrate Premium extraction, whatever way you're getting that file system, you'll actually see that there's two tracks that we have to follow. There's the app source location, which is actually where the app itself, .app, lives. And here you can see the application data location. The data location is where we actually want to go look for the stuff that we care about. The documents, the data, the SQLite databases, and the plist files. And of course, I had to use Twitter because I pretty much live on Twitter. But there's an amazing artifact that we really started looking into, and Alex was one of the ones that turned me onto this, but it was the application state DB. The application state DB is your treasure map. It tells you where these artifacts are actually listed and where you want to go find them. Now the problem is in an offloaded app, unfortunately, even though only that top container is deleted, the application state DB removes both traces here. So your treasure map will not have the location that you want, even if that app is offloaded. So there's no directions for us. We can't look for that. Now the mobile installation log, which is a fantastic log file that can give us some information about this, may track this. But they don't track it in the way that we would hope. Because when you actually offload an app, you don't get the same tracks in the mobile installation log that you would if you deleted the app. Typically, we'll still see a placeholder being placed on the app to say, hey, it's sort of there, but you will see certain containers getting deleted. So the mobile installation log combined with the application state starts to get a little murky and confusing. The best part about it is that the bundle ID that we talked about earlier is still searchable regardless, and you can search the file system of the device to find this. If we look through this, every specific application is going to have a bundle ID.plist file that we can look for. But you can also check this plist file, the icon state.plist, which is part of the Springboard. This will list out in order every application that's installed on the device. Offloaded apps will still appear here as if they existed. Now the trick is to actually run a differential and determine, based on what the phone is saying is installed through icon state, and then what the file system sees as part of the application state, what really has been offloaded. And that's been, from my finding and testing, the best way to determine if an application itself is offloaded versus truly deleted. But again, we come back to searching for that bundle ID. We want to search for the bundle ID. We want to look for that .plist file in the preferences folder, and that source path is going to give us our UUID for the app itself. So how do we find this bundle ID? Well, hopefully you know what it is going in, but you may not know that, for example, Twitter is com.8bits, spelled A-T-E-B-I-T-S, that's a little pun for you, .tweety2. You may have no idea what that application bundle is. So there's actually an easy way to do it. And in our training department, we like to say GTS or Google that stuff. So what we're going to do first is we're going to search for something like Reddit iOS app, thanks to Google. And that's going to return a result, hopefully, that comes back to apps.apple.com. Now, when you view the actual online iTunes page for that app, you're going to find in the URL, it'll end with ID and then a numerical value. This is the numerical value identifier for that app, similar to the bundle ID. If you take that numerical value and you put it in that following URL with the itunes.apple.com lookup and paste that in, you're going to find a text file. An actual text file gets downloaded, and this text file, once you put in that URL, it'll automatically download this text file, and inside of that, you're going to find bundle ID. So now we know that the app we thought was called Reddit is actually called, in the file system, com.reddit.reddit. Now, this one's an easy one, but what if you have one of these off-the-wall apps? Something like, I don't know, you would have one called com.nh-secret messenger. And what is that? Well, you would have no idea that that app name is actually called anti-chat, unless you found the blog that I did on it like 6 months ago. Other than that, you would have to use this process to find out, well, I see this app in Springboard, or I've heard about this app that they're talking about called anti-chat. Now let's actually find the bundle ID and see what other data I can find. So once we search for the bundle ID, this is a small collection of some of the artifacts that we'll get and that we talk about. Of course, the mobile installation logs. My new favorite plist called the Uninstalled Applications.plist. Apple did make it a little easy for us. DAP.SQLiteDB, app purchase history 6.SQLiteDB, screen time, which is an amazing artifact, and of course the ones we know and love, PowerLog, PLSQL, and its archived formats, KnowledgeSee DB, data usage, net usage, and then call history. How can call history help us track deleted apps? But we'll cover that too. So on the mobile installation log set, in private var install D library logs, and I won't read all these, I promise, you're going to find either a 0 or a 1 from our testing.log file. And in those log files that are in there, they're going to track when these containers are actually moved, which for whatever reason, Apple likes to move the containers on a seemingly random basis, but they do it all the time, sometimes for updates, and sometimes maybe just because they feel like it. So that treasure map is going to constantly be shifting, but we're going to see when these containers are installed, uninstalled, moved, if they're destroyed, and of course the destroyed is the one that we really want to focus in on. It does give us a timestamp of when that occurred and a direct path to where that app should have been when it was deleted. And of course, Alex did an amazing job parsing these out, and from his GitHub, you guys can actually download his parser that we did there, that he did there, and actually run those out. So here you can see, hopefully, an example of that. This is actually output from Alex's tool. It comes out as a SQLite database. I love SQLite. I live in SQLite, so I use the SQLite. But he went a step farther and actually made text files that actually list out a lot more detail than this. But you can actually see an example of these, of the bundle ID, the action that actually occurred, whether it was installed, uninstalled. You can see here that some containers here were made live, or in the bottom you'll see uninstalled, uninstalling identifier, and then you'll also see destroying container from where we actually removed an app from a phone. My new favorite plist file in the iOS file system is called Uninstalled Applications.plist, and it sits one level up from the mobile installation logs. Mobile installation logs don't seem to track everything. From our testing, they seem to be, there's only going to have a 0 or 1 .log, and they're record-based. When they run out of room, they run out of room. But this guy doesn't. The Uninstalled Applications.plist will tell you every app that has been removed from a phone. Now, how did that app get on the phone? Well, it was either downloaded through the iTunes Store, or it was side-loaded, or it was loaded as thanks to a backup procedure. But when the app is actually removed and kicked off of there, it comes in here in the installed applications.plist. This only tracks deleted apps and not our offloaded apps we've previously discussed, but it gives us a bundle ID and a date and time of the removal. And this is that example I used to tell you guys that I found records of apps that I'd used 9 months prior and deleted just sitting in here waiting. We also have DAAP.SQLiteDB. This particular file lives inside of a cache, and Apple is using this. This is just like the mobile installation logs and the uninstalled applications.plist. Those you do need a full file system to obtain. But DAP originally stood for the Digital Audio Access Protocol that Apple uses for sharing their media. However, they're using it here to actually track a lot of apps that you're downloaded. And this will actually tell you all apps that are actually purchased, whether they are on this device or not, by that Apple ID. So if you find a bundle ID or your target inside of this database, that means that your suspect or your individual has purchased the app, and at some point it was downloaded somewhere, but we don't know exactly if it was 100% this device. This could be any of their iOS or macOS devices that they have tied together. This one is added in iOS 12, and there's a duplicate database that exists from previous. But it also lists who bought the app, because there's a whole thing called family sharing. And if you have multiple people as part of a family plan buying an app, you do want to make sure that it's that user that you're targeting has actually bought that app. So App Purchase History 6 is a very, very similar structure to DAP. Lists out the app purchased by the Apple ID holder, includes the original purchase date, and this is also found in older versions of iOS. So while DAP from our testing was iOS 12, App Purchase History 6 was 10, 11, and 12 from what we could see so far. Screen time. Now, screen time was added in iOS 12, which is amazing as part of this remote management RM admin store -local or -cloud if they have multiple devices in here. And it actually allows you to track daily usage of apps. It only stores approximately the last 7 days for app notifications, pickups, and unlocks. But the best part about this is that synced applications can stick around a lot longer. That means that if an application has been reporting to screen time, even if that application hasn't been used in the last 7 days because you deleted it 2 weeks prior, it may still be there. The actual application usage of that app may be gone, but the actual synced application may still remain. Again, sometimes. This is where it starts to get a little weird because Apple doesn't always report these into that database. PowerLog, PLSQL, thank God for Apollo because there's way too much data there to ever interpret. But thanks to Sarah releasing Apollo, we actually were able to get through this particular file and find a lot of deleted app tracking in here as well. It will list offloaded apps as deleted, so be careful on that one. I mean, the app is deleted, remember, but the documents and data still remain. It does help track usage and deletion times. But the timestamps were a little bit different from table to table for us. But again, we could not have done any of the work we did with PowerLog without Apollo on that one. So you can see several of the entries here from the different tables, and you'll actually see that we have an app deleted date listed here in our SQLite viewer that actually is showing you the bundle ID and the exact date and time that those were deleted. Now, the app deleted time and some of the tables were rounded to an hour value. They didn't give us an exact minute and second, but some of them did. So please, with caution, use PowerLog because each timestamp is a little different. And as we always say, test, 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 test. The KnowledgeSee database, again, we all know how incredibly valuable this is, but this can also track application install and uninstall dates and times. We also get the application in focus. So when that app was actually in focus on the device, and even after the app is deleted, we have found records of those apps sitting here. So you can see that, and this has nothing to do with the fact that Zoom was hit with a massive attack recently, or vulnerability discovery, we should say, and Apple pulled it off of a lot of Mac devices. Around that same day, I happened to remove it from my iOS device just to be on the safe side. And you'll see here that you can actually see that this app was in focus thanks to KnowledgeSee, and this is well after that app was deleted. Data usage and net usage are two great artifacts, very similar to SRUM, but for iOS, that can actually track the bundle IDs that are getting utilized and also track how much data they're sending across the wires. So there's two main ones. There's datausage.SQLite, and this is actually found as part of the wireless domain inside of iTunes style backups or private var wireless library. This is a great one because you can actually find this without a full file system, and it's one of the few places that do exist without a full file system to track this. But unfortunately, this database only seems to track cellular data usage. It's not telling us how much data is sent across by that bundle ID through Wi-Fi or through a wired Ethernet connection, only through cellular service. So the app does have to be, in my testing, at least connected to a cellular network once. A couple of apps that I installed only used the Wi-Fi, made sure they couldn't have sending data in the background, and then deleted without that, didn't actually get tracked here. But it does seem to keep longer records of deleted apps than its net usage counterpart. And it does actually track several usage timestamps because of the way that it logs processes and apps individually. You can see a very tiny screenshot of that, hopefully, but you can actually see here our Zoom, US Zoom video meetings bundle ID, as well as several timestamps when that was utilized, and exactly how much data it was sending across the wire there, incoming and outgoing on the cellular network. For net usage, it's actually cleaning up after itself a lot better. Very similar structure. In fact, the actual query that I ran on both of these tables, both of these databases were exactly the same. The only thing that changed is the actual process ID changes from one table to the other, but the query is 100% the same. It does seem to be doing a better job of clearing deleted apps. This one, however, will track Wi-Fi, cellular, and wired data sizes with multiple potential timestamps again. It does tend to remove a little quicker, but it can still be carved for, and we have found records in the net usage too. So how about just records in a database? And I mentioned earlier CallLog. How in the world could CallLog actually help us track deleted apps? Well, if I happen to use an app like Zoom, and I made a call with Zoom, it actually puts a record in my CallLog that says I used Zoom at that time to place a call, which means that it's going, in some cases that we found, get dropped into KnowledgeSee for app intents and all these other places. Well, thanks to this, now they changed this on us, unfortunately, about 2 weeks prior to finishing our talk. We noticed that when you delete the application, it does reach back out to the call log and deletes any records from the call log that had to do with that application. In the past, it hadn't done that, but in last testing, it did. So when you carve that database, you can still potentially find this. And this is, in this case, just simply spitting this out to CSV after we loaded the database without the WAL file. And we were able to load it in without the WAL file and actually find that we still had that Zoom record in there. So if you see that, it will potentially, in the call logs, depending upon the app, track when it was used, and it could also be tracking who they were talking to with that app. A lot of apps have the ability to call out to the CallLog API, so please, please, please never overlook that amazing piece of data. So what are our takeaways from the iOS side? Well, some apps were there and some apps weren't. We are dealing with deleted data, which means there's not going to be a concrete way of doing this. But hopefully some of those artifacts that you've used, you can use in your methodology for finding them. The less time passes, the more potential data you're going to have. If they delete the app a day or two prior to you seizing the device because they're onto you, or they know you're onto them, or they have whatever suspicions and they go and delete the app, you're going to find a lot more data than in the cases of the apps that I deleted 9 months prior. So there's different ways to think about it, and of course with iOS we know this is going to constantly evolve. With iOS we're tracking this a lot more through native apps, but Alex is going to tell you about ones that we use through non-native apps in Android. So how do we timeline this? Well, first of all, we always want to look for app purchase times. We're going to do that through DApp and app purchase history. We're going to look at potential installation times thanks to our mobile installation logs. We're going to look for usage and communication times when these apps were active on the networks. Data usage, net usage, and PowerLog can give us some of that information. When the apps were actually last in focus, anywhere between the last 7 and 30 days or more, thanks to KnowledgeSee and screen time. And finally, when they were deleted using apps like the mobile installation log, artifacts like the mobile installation log, the deleted applications plist, or using the PowerLog PL/SQL or its archived copies. So this sort of timeline of activity is what we're finding the best way of tracking this data and putting it all together. And so with that, I'll give it over to Alex, who's going to talk to you guys a little bit more about Android.
Thank you so much. With Android, it's a different ballgame in the sense that it's so fragmented, right? You got all sorts of vendors, LG, Samsung, and even between the operating system, so many versions of Android. And vendors are still putting phones out to sell that are 2, 3 versions removed from the latest Android, right? So like Chris said at the beginning, it's some methodology, right? Some steps, some things to consider. So for this section, let's talk quickly about native to Android. And this type of an example artifact should be in most, if not all, Android versions. I'm going to talk about vendor installed, which are the uniques. I only selected Samsung because it's the most popular vendor for Android, but you can select on your own research any other. And third-party apps that you get from the Play Store. So for user stats, it's the first one. I send a lot of hearts and appreciation to Jessica Hyde, back there. She did some of this research and presentation in the last DFIR summit. I'm not going to rehash the whole thing. There's not time for that. But something important to keep in mind is that the user stats, they keep activity of the apps, even if the app was deleted, which is what we're interested in. Just a quick summary. You got your daily, monthly, and weekly activity kind of XML reports, for lack of a better term. Those reports are in epoch. Timestamp name, file named. Within those, you got last time active, the package name or bundle ID, in the case as we're talking with iOS, time active in milliseconds, last event, and how many times the app was launched. The last time active is too short to be an epoch time. It's milliseconds offsetted from the epoch time that the file is named after, if that makes sense, right? So there is some math involved to get that to an understandable, human readable date, right? And that's an example of how that XMLs are processed and how it would look. And you get your dates, you get the different apps, you can tell if the app is in the foreground, in the background, and what type of classes within it are being accessed, right? To make that easier, there is a Python script that I did that does that all for you, and you get a nice report of the usage stats, and you can look at what apps were there, okay? Now the major vendors are also supporting this artifact, which I'm pretty happy about. Right, the context log. The context log belongs to Samsung. It's a vendor-installed functionality. Based on my online research on it, it has to do with a way for apps to share data among each other. And the context log in the use app table, it will tell you, it gives you a timestamp, both in epoch and human readable, and a time offset, the app ID or bundle ID, and the app sub ID. That's how it's called on the table. The app sub ID is if you're using, let's say, Telegram, and you're chatting, usually the name tells you that it has to do the activity with chatting. If you're in the splash screen, usually there's words there that tell you, oh, it has to do with the splash screen. So you can kind of give a characterization of what's happening, okay? Testing is involved in that. I see chat, it might be something else. So I test and make sure that when the app sub ID is about chatting, it's actually chatting, all right? Take into care and this log, you have your dates, and I took out the human readable dates so they could fit here on the screen, but be careful, right? So if you're offsetting and you take care of the offset, you're gonna have two different dates. One is epoch and one is local time. So keep that in mind. All right, I'm gonna harness my inner Jessica and go forth really quickly, so bear with me. Well-known Android databases, and this pretty much is covered by FOR 585, mobile here in mobile course in SANS, local app state, library DB, and package verification. They have to do with the Google Play Store. And when apps are downloaded and placed there, there's some information that you can find. It might reside that information even if you take the data off. So you know that at some point this app was downloaded to the device, okay? All right, so vendor install, Samsung members. This app will run diagnostic, keep track of RAM, and also keep track of apps, right? It used to be called Pocket Geek. Now it's rebranded. It's installed by default, and it's really paying to get off sometimes, some of these applications. There's the path, and there's a couple of databases that you might be interested in, inventory and one for the device events. What do you have in inventory? You have the display name of the app. For example, for this one, it would be Samsung members. The package name, in this case, would be Pocket Geek. And that's an example of what Chris was saying, that your bundle ID or your package name can be different from the actual application name. So you have to keep that into account. It will tell you if it's a system app, a Boolean value, 1 yes, 0 no, and when it was last used, right? And this is how that looks. You can see on the screen there some of the display names and the package names and their times, right? And the next one, it's even more interesting. It takes that data you saw for the inventory apps and puts it in context. So I'm going to go quickly to the table. You'll see events like package installed event. Super useful. It tells you when that app hit that phone. And within it, you have all the information in the previous table. It's also added within this database in JSON format. All right? This is super useful because now you can bracket the activity. You know on this table when it was installed and from the inventory of the application when it was last used. So you can really bracket that activity from that app even though it's not there. And if it matches some of your activity, as an investigator, when I said your activity, what I mean by that is things that you knew happened at those times, then you can put those two and two together, all right? Smart Manager, another example of vendor installed applications, right? It takes, long story short, it takes data, applications that are in use, using too much battery, it puts them to sleep for a little bit to kind of manage the battery. When it does that, it keeps a lot of information in its database. There's the path of where you can find it, the SM or Smart Manager database, and the low power context database. That's when it kind of shuts down the app. All right, package name again, the start time and the end time. I did not mention, but I should mention quickly. The crash log, let me see if I can go back here. Yeah, the crash info, I didn't show it, but it's a simple application and when it crashed. That's it, which is also useful. Just to know that that application at some point crashed means that for it to crash, it had to what? It had to be there, right?
And Android apps never crash, right?
Oh, that never happens. So I feel some Android hate, I don't know. So the low power context, right? Package name, this is how it looks. There's your application and the times it was put to sleep. All right. Now, uninstalled third-party apps. I really like this a lot because no matter what type of Android device you have, if you're getting third-party apps, which everybody does, some of the behavior is pretty much standardized, usually because of the app. Not always. As you know, there are apps that are designed from different Android versions. But for the most part, in my experience, they tend to be pretty kind of equal across the board in regards to the data stores, usually. So CCleaner is super common. It's been there forever. When I took this screenshot some time ago, 50 million people downloaded it. This is really interesting also because the data, you can get to it by just doing an ADB backup. We were talking about some of that data, for example, in iPhone, it has to be jailbroken. Sometimes in Android, it has to be rooted, right? Some of these apps will throw all those databases out at you without having to root that phone, which is super useful if you have a phone that you can't root or you're not allowed to root per policy, for example. All right. So as an example, we have the databases for the app. That's how it would look if you the phone is rooted. If you look at an ADB backup, it's the same format you expect. Again, FOR 585 has all the details. All right? Databases that are interesting, Cleaner Apps, and the Scanner Cache. So what is that? Cleaner Apps is just a list of all the apps on the phone that are to be scanned or cleaned or looked into. And again, it will keep track of apps that are not there anymore, which is super useful. The Scanner Cache, it tells you when a particular app was scanned. In this example, the Delphi Coder Flood, it's a BitTorrent client. I come across BitTorrent all the time in my cases. And it tells me that was scanned the last time at whatever date it is. Again, super useful to indicate activity. The phone was on. There were things happening on the phone, right? There's other artifacts we cannot cover on CCleaner in regards to automated scans. And if there are no automated scans scheduled, and this app was scanned, guess who scanned it? It had to be a user-generated scan. Does that make sense? So you can start to put together a framework what's happening with these apps, even if they're after they're deleted. And I would add quickly, this research from my end came from looking at Sarah's work with Apollo. I've been obsessed with pattern on life, but for Android. The same way that she does it for iOS, I want to do it for Android. And that led to the conversation of, look, all these deleted apps still live in the memory of these artifacts, right? And that's why that we're here today. The three examples that I gave, fourth, with CCleaner, all of them, I have a SQL query repo in my Git. You can go there and pull those queries that I generated to create those. Quick mention that the Magnet Forensics portal is free for everybody. It's the same queries in an XML wrapper or Python scripts that you could use. Just pull them free. And I have them on both places and to get as much distribution of those as possible to help us as much people as we can. And you got something else?
Yeah, so the one thing that is worth mentioning, we didn't unfortunately get time to add it in, and we do want to try to take any questions we can, but what if we can't get access to the full file system in these cases? Don't forget your friendly cloud. What we have found in our testing is that both Apple and Google are tracking a lot of the information around these application usage, when they were installed, when they were purchased, and potentially even when they were updated from our testing. Now in iOS, they'll actually tell you when the apps were installed and when they're updated. If you want to test this out, simply go to Apple's privacy page and do a copy of your download your data. The amount of information in those CSVs about your app usage is staggering. If you think that's bad, you should check out your Google Takeout. If you have an iOS or Android device, it will actually log when you're using Google Apps on your phone. I have an iPhone because I'm not an Android user, but yet my Google Takeout, because who doesn't have Gmail, can still tell me when I launched Google-specific apps on my iPhone, even if I remove those from my device. So just because devices themselves don't have the data doesn't mean it's somewhere. So you should always go out and check the cloud as well. And with that, I think we are totally out of time, but if we have time for questions, we'd love to answer them. If not, we're here all week.
Absolutely.
All right. Thank you, guys.